The mathacademy.net welcomes you to the simplicity of infection math. Part 1 will be about the two infection formulas, exemplified with data from Denmark in 2020. Part 2 will be about the Danish lockdown. Infection follows two simple formulas that predicts its behavior. The first infection formula is a three-factor formula. It tells us how infection spreads. For example, infection may explode in unbalanced meetings, where many persons are together for many hours. Therefore, balance meetings in space and in time. Few persons in many hours, or many persons in few hours. The second infection formula is a Hill formula. It tells us that if balanced, the infection will disappear by itself. In a shorter period, with higher infection intensity, and in a longer period, with a lower infection intensity. Therefore, the message of the two infection formulas is, do not exceed. Do not lock down. Simply balance. Infection reproduces, and the basic reproduction number is called R. It tells us how many persons that one will infect. Typical reproduction numbers are 2 and 4. For Ebola and SARS, and 2.5 and 1.5 for corona and flu. If the reproduction number is 2, one will infect 2, that will infect 4, and the infection will increase. If the reproduction number is 1, one will infect 1. That will infect 1, and the infection will stay constant. If the reproduction number is a half, 4 will infect 2, that will infect 1, and the infection will decrease. The first infection formula is a three-factor doubling formula that is quickly found on Google. The formula finds the reproduction number, R, by multiplying the three infection factors, the dirt factor, the crowd factor, and the time factor. Therefore, my infection risk doubles if I double my lack of hygiene, or if I double my crowding, or if I double my meeting time. Doubling formulas are all over. Nature is full of doubling formulas. They describe proportionality in the STEM subjects science, technology, engineering, and mathematics. Here are some examples. We should notice the extreme power of three-factor formulas. In a two-factor formula, 10 doubling needs 3 doubling, since 3 times 3 is close to 10. In a three-factor formula, 10 doubling needs only 2 doubling, since 2 times 2 times 2 is close to 10. The pressure formula is used to generate steam pressure difference in power plants. The reproduction formula is used to generate virus greenhouses. The three-factor infection formula shows that afterskiing will create hot hotspots, where extreme doublings of all three infection factors, dirt, and crowd, and time, will create effective virus greenhouses. We see that a 5 doubling all three infection factors will create a 125 doubling, so that one will infect more than 300 persons at an afterski party. But the three-factor formula also shows that the reproduction stays constant by balancing the three infection factors. So, with standard hygiene, that is using soap but no alcohol, the combined effect of crowd and time is an area that is kept constant by balancing the changes. Therefore, halving the time will balance doubling the crowd. And doubling the time must be balanced with halving the crowd. Therefore, the message of the three-factor formula is simple. Do not exceed. Do not lock down. Simply balance. A lockdown will prevent infection from terminating at herd immunity, where 60% of the population has been infected. A simple game will show why. In a group of 6 persons, in turn, the players choose one person to infect. The chance of success decreases, and soon the chance is down to 40%, where herd immunity occurs. The second formula shows the infection termination as a hill curve. It shows that the infection increases when the reproduction doubling factor is over 1. And decreases when the doubling factor is below 1. And because of a limited population, the reproduction factor will decrease steadily from its initial level to 0 when herd immunity has been reached. Therefore, a decreasing doubling factor will make the number of newly infected first go up, and later go down. The only question is, if the top is below or over the capacity of the hospitals. Solving its change equation will give the details of the hill curve. The equation occurs in 2 versions. The first version uses a spreadsheet to calculate and add the periodic changes, step by step. The second version uses calculus to transform the change formula into a level formula for the hill curve. To have reliable data, we use the number of hospitalized, since we are not able to measure the total number of infected persons in a population. The number of hospitalized then allows finding the number of respirators needed. Here we see the Danish data for persons being hospitalized daily. We focus on the period until the 26th of March, when the effect begins to show of the Danish lockdown, proclaimed on the 11th of March. The period up to the 11th of March showed an average daily growth close to 50%. This corresponds to a daily doubling factor 1.5, coming from people infected during Italian afterskiing. The following week showed an average daily growth close to 30%. This corresponds to a daily doubling factor 1.3, now also coming from people infected in Denmark. The period from the 11th of March to the 26th of March showed an average daily growth close to 20%. This corresponds to a daily doubling factor 1.2, now primarily coming from people infected in Denmark. When meeting an infected person, some are infected, some are not. If infected, some are sick, some are not. If sick, some are hospitalized, some are not. If hospitalized, some need a respirator, some do not. A 5-day horse show in the Danish town Herning from March 4 to 8 helps estimating the different percentages. Here 50,000 persons were together for 5 days. This means that all 3 infection factors were doubled up several times. This would indicate that all were infected, but only 30 were hospitalized. Therefore, the ratio between the infected and the hospitalized may be estimated to 50,000 to 30, or 1,650 to 1. Danish authority data shows that in average, 5 beds need 1 respirator. In total this means that 5 million infected need 3,000 beds with 600 respirators, which is below the capacity on 1,000 respirators. Therefore, the message of the horse show is, no crisis. The same message comes from observing that the problems in Italy first occurred 2 months after the infection arrived from China. Therefore, on the 11th of March, with reliable hospitalization data, the 2 infection formulas would say, with a doubling factor 1.5 created in afterskiing, we will reach herd immunity in mid-April, needing a maximum of 800 respirators in late March. With a doubling factor 1.2 created in Denmark, we will reach herd immunity in mid-May, needing at maximum of 400 respirators in mid-April. Both respirator numbers are below the capacity at 1,000 respirators. Consequently, the infection will behave like a flu. Therefore, to avoid Italian after-skiing numbers, we maintain normal hygiene, that is soap but no alcohol. And we balance meetings in space and time, by keeping the person times hour area below 100 for the next 3 months. Here ends part 1, concluding that, with reliable Danish data, the message of the 2 infection formula is, do not exceed, do not lock down, simply balance meetings in space and time. Part 2 will be about the Danish lockdown.